Okay, so here's the slide we were on, and we asked what is the actual instantaneous rate of change at this point. And I'm just gonna quickly write up the work. Well, I assume you have it. Do you have the work that we showed for the difference for actually doing the limit as h goes to 0 of f of x plus h minus f of x. So the way we wrote it was the limit as h goes to 0 of f of x plus h minus f of x all over h. And in this particular case, we did this. And in the end, we found that the answer was 4. You remember that? Okay. So let me just can I do this a second time, please? Just for fun? Okay. But this time, I'm actually going to work with this expression, right? And we're actually going to see what we get here. Okay. We're still working with the same function. So x plus h squared plus 1. That's f of x plus h minus x squared plus 1. That's just f of x all over h. I'm doing this in general with just the still the x plugged in, not with the 2 plugged in. Right? At the end, at any time, we can plug 2 in and come back to the real world if we want. Right? But it's kind of fun to just do this with an x. Let's see if we can. And you tell me why this is going to be a powerful thing to have if we do it with an x in there. Talk to me about that. Stuff cancels out. You see it? That's an exciting moment for us. Boom, 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 boom. Okay, so we get a limit as, by the way, keep this limit in front of all of these until we've actually evaluated it, please. 2xh plus h squared is all that's left up top over h. And what do we get? Sorry. Did I say that right? Yeah. Yeah. So what do we get? Yeah, pull out an h, cancel it out, however you want to say it. You get the limit as h goes to 0. We've been wanting to plug in 0, and we haven't been allowed to until right now. Okay, so what's the limit evaluate to? And like I said, at any time, you could plug back in x equals 2 if you like, couldn't you? And we can do that now. What do we get? If x happens to be 2, we get 4, which is what we got on yesterday, whenever that was. Friday, yeah. Right, we got 4. Didn't we? But why was this useful and powerful? This is not just for fun. What's cool about what we just did? Yeah, we can do this for any value now. And we've already done the work once. I'd rather not do it again. Would you like to know on this parabola what the slope is at x equals 3? It's 6. What's the slope at -1? It's -2. What's the slope of 0? Looks like 0 to me, doesn't it? To you? So this is pretty powerful. What we have here is like a little function here that generates the slopes for us, doesn't it? Or the instantaneous rate of change, or the slope of the tangent, or any of the ways we've said it. So this is a powerful idea. I might actually show you one more way to calculate the derivative later, but let's keep moving for now. Now, someone might, again, as usual, ask you, once you've done that work, to do, there's the picture. Oh, and I have a nice graphic here. Look at my PowerPoint skills. You ready? Watch this. Come on, h approaching 0, everybody. You want to see that again? Yes, you do. Bam, little secant becoming the tangent. Okay. Strong work, Mr. Chase, you're supposed to say. Okay. All right. Equals 4, we already showed that now twice in 2 different ways. Could someone ask you what the equation of the tangent line? Absolutely. Right? Because now, the hard work is done. The slope we have in possession now, it's 4. And the point, I told you, I guess, starting off, it's 2, 5. So I think we can write it down, right? Let's just not make a big deal of it and move on, right? That's a great way to write it. Another great way to write it would be to write, I like this way. There are a couple different ways conceptually. I kind of, this is good. I might also write it this way, 5 plus 4 times x minus 2. I kind of like it that way too. And by like, I mean structurally, right? It's almost kind of helpful for me to see it that way. Because it makes sense to me a little bit. It means, kind of shows me that like we start at a y value of 5 and then we increase by 4. Kind of like that. And can you write down the equation in normal soon? Any of these follow-up questions are just that. They're follow-up questions, right? I assume that you could write that down too. Yeah. Did you have a question to that? Or anyone? Anyway, if you want to do it in slope-intercept form, that's fine. Anything correct is fine. Yep. This is fine. This is fine. If you want to actually give me slope-intercept form, what would that be? 4x minus 3? Yeah. Apparently that's where this hits the y-axis down there. Okay. Let's go ahead and do this one right now. And I think there might be one like this in the homework too. Am I right? Which is great because we want to prove a point about this. Okay. Here's the picture. Okay. I think you can draw that picture even without my help. There it is. Are you comfortable with piecewise functions? So we're gonna take. What are we asking for the slope of the tangent here? That is the instantaneous rate of change. Well, by that we mean this again, right? Don't we mean the overall limit? And if we mean the overall limit, then of course we also mean, we haven't stopped to break it down like this, but we also mean the left and right limit, don't we? That's really what we all have always been meaning when we wrote this. We just kind of didn't mention it before. So let's think about the left and right hand limit, and let's work it out over on the board. Okay. Now, it may not be necessary to go through all this work for at least one of these two functions. Do you know the answer on the one on the left? We'll do it just because. But what should the answer be for the left-hand one? I think it's -1. Do you agree? Just to prove that like the math works here, let's plug it in and see. It'll only take a second. So negative x plus h. Do you want to plug in 0 now, or do you want to do it later? Do you like the powerful way to do it? Let's do it the powerful way. We'll keep the x in there. That'd be fun. It should be -1 for all x, actually, is what I'm thinking, right? So this is f of x plus h minus f of x all over h. We've got a limit up in front here, too. And just to be pedantic, we're talking, for this particular situation, about just the limit from the left. Okay. So the setup looks good to you? Yes. And then, of course, simplifying this is not very much work at all. What do we get? Simplify the whole numerator. Go. -h, I hear you say. Okay. And of course, what do we get? I mean, there's really not even a limit to take once we do the simplification. What is the limit of this crazy function as we tend towards 0 from the left? Well, it's -1. I mean, right, there's not to me h left to even do anything with. Great. That's, by the way, confirms what we thought of already. We thought it was going to be -1. It sure is. Let's do the one from the right. This will be quite a bit more fun. From the right, we have a different function to use here, don't we? We have x plus h cubed minus x cubed over h. Are you feeling this second step? Are you feeling that second step? It's just a composition with x plus h plugged into the function, and then just normal f of x, right? You subtract carefully, watch your signs everywhere. Okay. And so this does require that we expand that out, but I think we all know that that's x cubed plus 3x squared h plus 3x h squared plus h cubed. Okay. Cool. You can work out the details on the side if you want, but maybe you've seen that before. And then, now this is the fun part. Cancel some things out maybe, can we? Well, not too much, just the x cubes. So we get 3x squared h plus 3xh squared plus h cubed over h. I'm going to need a second line for this guy. knocking an h out of everything gives us what? 3x squared plus 3xh plus h squared. And now, finally, we've been waiting for the moment that we could plug in 0. And now we can. And what do we get? If you plug in 0 here for h, that is. We just get 3x squared. And if x happens to be 0, we get a slope of what? If x is 0, then we get a slope of 0. Okay, we'll start using more technical language for this soon. I promise. These arrows are maybe not a little sloppy, but I think we've just shown that the slope on the left, the left-hand slope, whatever how you want to say that, is there. I didn't actually work it out, but there we go. There's the details are on the board. Is -1, and the slope on the right is 0. So what can we conclude? Yeah, what fails to exist here? At 0. Yeah, the slope, the instantaneous rate of change fails to exist. The slope at that point fails to exist. But I want to make sure we're clear here, because obviously there is something that does exist here. There's all sorts of things moving. Sorry, slope of the tangent. So the slope of the tangent does not exist. We just showed that. The left and right hand limits that give an expression for the slope on the left and right don't agree. So this function doesn't have an instantaneous rate of change at that point. But let's not confuse these two concepts. What is the limit of this function as x approaches 0? It's 0, and it's perfectly well defined. This function is continuous. It's very well behaved in that sense. Okay, so don't confuse the two. Someone asks you, does the limit exist here? The answer is definitely yes. But does the slope of the tangent exist there? No. We can't make a choice of what tangent line to draw, right? We're not sure. Okay, more things moving. Okay. Is that clear, that distinction in your mind? Maybe? Okay, I have one more slide to show you too. Wait a second. Let me give you 2 gifts. You can pass those out. Albert, you look like a man who wants to pass something out.
Yeah, absolutely. I want to give a book.
What thing? Okay. All right. So there are a couple things coming to you here. There are 2 worksheets and a. Well, you'd be mistaken if you thought that was a pink index card. It's actually, the pink index card is not a pink index card at all. It's actually a tangent line drawing tool. Yes. Okay, so make no mistake, it's not an ordinary pedestrian index card. So you may want to keep this forever and treasure it. You may want to write its purpose on it so that you don't forget, in case you accidentally someday think it's just an index card. Okay, write, Marcus's tangent line, super duper tangent line drawing tool or something. You'll need that, I think, as you graph some tangent lines. Just approximately, you're going to be doing that on that cubic curve picture that you can have on one of the worksheets. So I'll say something about drawing tangent lines in just a second, because some of you may it's actually an acquired skill for many people in the world. So I will coach you in a minute. just to kind of capstone where we are here, like we've talked about two big ideas over the last day and a half now. Average rate of change versus instantaneous rate of change. Slope of the secant versus slope of the tangent. Secant will hit the curve twice in a local area. I want to add that piece because obviously a tangent line could hit a curve somewhere else a second time. But in the local area, it only hits the curve once. Okay. We're using 2 points to calculate an average rate of change. Instantaneous rate of change is a slope at a specific 1 point. We can think about the slope of a tangent as being change in y over change in x. But here we need to think of the change in y over the change in x where the change in x becomes infinitesimal, right? Where the limit as delta x approaches 0 is what we're talking about. In more words, we could write it this way. Or this way. Right? Does this work? Could you do it this way though? Let me just quickly demonstrate with was it x squared plus 1? The one we were doing earlier?
Yeah.
At x equals 2? Okay, let me just demonstrate how you can use this definition too, and again, just to demonstrate that math works. Let's use the f of x minus f of a definition. So f of x minus f of 2 will be at 2, say, limit as x and 2 get close to each other, right? Over x minus 2. I mean, theoretically, that should work, too, shouldn't it? Let's do it. Let's see if we get 4 this way, too. So this is x squared plus 1. This is 5. Sorry. Yeah, whatever. Pretty good. So this is x squared minus 4. You see where this is going, you guys? Come on now. You finished the word. Tell me if you get 4. Okay? Yes? Okay. I just want to make sure you understand that like calculus works. So this is a great definition. Does this work too? Sure. Sometimes the algebra is easier one way than the other. Like, you know, in this particular case, it involves some factoring, and it didn't seem to involve any factoring when we did it the other way. So, you know, literally. Okay. So, but that will get you 4 if you continue to work. I trust that you can do it. All right. Now a brief lesson on drawing tangent lines. You ready? He's so excited. I love it. All right, so just draw your attention to the cubic worksheet function picture there, and equip yourself with your tangent line drawing tool. And you want to draw your tangent lines as accurate as possible. And then once you draw them, you're going to count boxes. But let me apply some coaching as far as how you should think about drawing a tangent line. Because some people like draw one. I walk up to them and like, it's not really what we're going for there. Like some people might come along this point right here, say, and I don't know, some people, I think it's almost, there's almost like a tone deafness in some people. It's like people come to this and they're like, I don't know, you know, I don't know, and I'm like, that's not tangent to the curve. Or at the top of the curve, people are like, that, like that, right? I'm not, in fact, I'm pretty sure that there's a point at which the slope and the tangent line is what? Yeah, there's got to be a point at which if these tangent lines kind of happen the way we think they should happen, there's got to be a point, and if it's not that point, then I don't know where it is, where the tangent line is 0. I think that's where it should be, and yet, what's this person doing, right? Okay, don't be that person, okay. So how would you conceptualize drawing a tangent line? One way would be, if you're along some curve, would be, if you were a car, top view, and you're driving on this road, which way would your headlights point and your taillights point? And the answer is, your headlights would point this way, and your taillights would point that way, wouldn't they? Okay. Or more morbidly, if you're going really fast, which way would you fly off the road at that point? And the answer is this way, okay? Or if you're headed this way, that way, right? That's, again, it's a little morbid, but, or, okay, now side view of a roller coaster, another way to think about it. Which way would you be looking as you were here, right? And the answer is this way if you were traveling this way, or if you're traveling this way on the roller coaster, you'd be like that way, right? With your hands up, of course, right? Isn't that how you ride a roller coaster? How else can I coach you? No, those are I think that's it. Do I have anything else? Oh, no, one more piece of coaching advice. If you were to zoom in really far on the graph, and we'll talk about this idea more later, if you were to be like here, and someone were to tell you, you don't know the world around you, and someone were to tell you, hey, you're looking at a line, you'd probably believe them, because locally it looks that way. And then if you were to just be that person and draw that line, what would it look like? Right? Would be another way to coach you, right? Here, to this person, this function is this line, right? Okay? Oh, sorry, I'm getting stuff. All right. All right. I think that's all my coaching. Go and draw good tangent lines. There's another worksheet too. If you guys would just, we had some squish time today, but not a ton. So I meant for you to try some of these things in class, but if you guys would just finish those 2 worksheets for Friday as well. And also finish homework 1 if you haven't already. So for Friday. Tomorrow, the only thing you need to do to come tomorrow is to be ready to take a quiz. Okay? But I'd like you to have these worksheets and homework 1 finished for Friday if you haven't done so already. When do you come in on Friday?